Imagine these two walls are standing on the ground. Now suppose I start pouring water into this wall. Between these two walls, this whole things become a container. The space between them becomes a container. Pretty much straightforward. Now here's my first question. What decides how much water this container can hold? Right? Think about it. So actually there are only two things that matters. First one is width. Now what is width here? The distance between two walls is width, right? If I move this wall far apart, the container becomes wider, so it can potentially hold more water. Clear. Now second thing is height. So if you keep on filling this container, the water will spill out from the shorter side, right? So how much water is actually present in the container depends on the smaller height of the wall, right? Smaller wall height. So height of the container will depend on the shorter wall. Now the area. So the third thing which we need is area. So here area will turn out to be height into width. Now height will be shorter wall, and width, as we know, the distance between these two walls. Distance between two walls. Great. So now we have our formula for the water between two walls or water in a container. Now let's jump to our problem. Container with most water, you are given an integer array heights where heights of I represent the height of the ith bar. You may choose any two bars to form a container. Return the maximum amount of water a container can store. As you can see, we are given an array of height, and this numbers elements of array represents the height of bar at that particular index. We have to find the maximum amount of water a container can store. So this is, if you see, we have already derived what is the area between any two walls, and that determines the amount of water. So if we are able to find somehow the area between all the pairs in this particular array, will get and then find the maximum area out of all those area, will get our answer. But this approach of finding area for all pairs is very slow, and it becomes order of n square solutions. Is there any better way? Obviously yes. Can we do it using order of n somehow? I think we can do that. Let's try that. We have this diagram where we have sequence 0, 1, 2, 3, 4 as index, and these are the heights of that particular wall. What if I use two pointers here? What is two pointers? I'll initialize my lower bound and my upper bound, that is L and R. Now I try to find the area. What is area here? As we have discussed here, area is the shorter wall into distance between two walls. So what is the shorter wall here? From 4 and 1, shorter wall is 1 into what is width? 5 minus 0. that is 5. So here area is 5. Now I'll reduce my window. So how to reduce this window? As we can see, my L is currently 1 and my R is 4. I can suppose that, or I can guess that, if somehow I move forward from L, increase my L, I may get in future a greater wall than what I currently have, that is 1. So if I increase L, now my L is 7, right? I mean the height at L is 7. So here is my new L and my R is same here. So now I'll find area for this. What is the area for this? The minimum of shorter side. So shorter side is 7 and 4. So 4 is the shorter side. And the width. Width is 5 minus 1. That is 4. That is 16. Next. Now, shall I increase L or decrease R? As now we know that R is currently smaller than L. That is 4 is smaller than L of 7. So I'll decrease R. So my new L will be same, my new R will be at 4. I'll again find the area and I'll get shorter of these two walls. So what is the shorter one? So 7 is the shorter one. So height is 7 into distance between these two, 4 minus 1, that is 3. 7 3s are 21. So like this, I'll keep on getting the area and then I'll find the max of all those areas and I'll get my answer. That is container with the maximum amount of water. Now that we have understood this logic, let's code it. So to get the pointers, I'll initialize it with L comma R equals to start of the sequence, that is 0, and R will be end of the sequence, that is length of height minus 1. Now I want to have a variable that will hold the maximum area. So max area equals to 0. I'll initialize it with 0. Now I will use while L is less than R as the condition, terminating condition for this while loop, and I'll check what is the area for the current window. So area will be shorter wall. So shorter wall is minimum of height of either height at L and height at R, and width. What is width? Distance between these two. So what is distance between these two walls? R minus L. Great. Now I'll find the max area. It would be max of area comma max area. Now I want to reduce my window. As we discussed, if our height of L is less than equal to height of R, will increase that pointer, let's say L here, because we want that somehow in future sequence this L might be bigger than what it currently is. That is, height at L might be bigger than what it currently is. If R is smaller, then we'll reduce R. At last, what we want? We will be return max of area, and okay, this should be heights, and let's compile it and submit. Yeah, we have got our answer. That's it. Thank you.